All right, guys, so this first one, it's an IBT question. A lot of you, it seems like, are starting to realize that you don't actually do very much on these problems. You know, you're just sort of like, okay, here's my answer. It's the same as the others. That's fine. That probably means you're doing it right. So you would just start out. I know it's given to you, but you have to state your first bullet point that f of x is a continuous function. Now, really, this is the only one that, these middle two are the only ones that kind of mess people up. It's f of 1 is less than 0 is less than f of negative 3. Okay, this is what I was talking about, where sometimes they're switched. You have to look at the y value that goes with the negative 3 and the 1 and make sure you put those in the right order. If you wrote it, like, you could do it this way too. If you really wanted to start with f of negative 3, that's fine, but you'd be saying is greater than 0 is greater than f of 1. So I would absolutely accept that. It just has to be a true inequality statement. Okay. All right, then your third bullet point, so there exists a C. And then we're back to x values now, so negative 3 is less than c, it is less than 1. Again, make sure that's a true statement. Don't tell me 1 is less than negative 3, because it's not. Does that make sense, guys? The order switching here is kind of weird. And then the last two are just gimmes, such that f of c equals 0. Last one by the IBT. Okay. How'd we do? Pretty good? Okay. So if you get one of these questions on the free response, like the paper pencil part of your test, I would want to see 5 bullet points, okay? Yeah. Essentially, yes. Yeah, don't leave out so there exists and such that. I can tell when sometimes people are like, they kind of partially memorize it. They're like, such that there's a C. I'm like, oh no, you're mixing that. So just practice it. It's the same every time, so it shouldn't be too bad. Okay, domain. Let's look at this one. This is a tough domain question because I've combined a lot of things. We have a fraction. We have a radical in the denominator. We also have an even radical in the numerator. So you actually have to pay attention to the numerator this time too. Okay, so it's kind of like 2 problems in one. So I'll start with the denominator, that x squared minus 1. That needs to be greater than 0, okay? It can't be greater than or equal to 0 because I can't divide by 0. I don't want that denominator to be 0. And then the second piece that's happening at the same time is that numerator, that x plus 2, that I can say greater than or equal to 0. Are we okay with those 2 inequalities? Like, does that make sense, the difference between the two? Why I'm writing what I'm writing? Okay. All right, so the x squared minus 1, I can factor that. And then what do I have to create to solve this? Number line, yes, I need a number line. Okay, so I'm putting -1 and 1 on my number line. Okay, I'm going going to test 0 because that's easy. 0 minus 1, that's negative. 0 plus 1, positive. So that region's negative. Now again, you can use the shortcut of, hey, there's no multiplicity, I know it's going to alternate, or you can test all the regions if that makes you feel better about it. I know it's going to alternate, so this will be positive, and this will be positive. Okay. It's asking me where is it greater than 0, so that's the two ends. It did not say greater than or equal to, so I want to make sure I don't include the 1 and the negative 1. So that's part of it. We're not done, though. We can't go to our final answer from there. I've got to go over here. This x plus 2 is greater than or equal to 0. This is a nice, easy one to solve. I just moved the 2, so x is greater than or equal to negative 2. Okay. We have to think about how these combine to give me one answer. So I'm going to redraw my number line just a little bit bigger so it's easy to see, and I can add this other piece on there. So I started with this. So x is greater than or equal to negative 2. I don't need a number line to solve that. I'm just going to place that on my other number line so I can see where they overlap. Okay, so I know negative 2 would be somewhere over here. And then I'm saying everything greater than or equal to that. So that would be starting at negative 2 and then going that way. So let me pause there for a second, make sure you're with me. So your actual answer for the domain is where it's true for both parts of this problem. So anybody think they know, looking at this number line, what my final answer should be? Anybody want to take a try? Are we tired and quiet this one?
X is greater than 1.
So I agree with that piece of it, that we're going to have a 1 to infinity. I like that, but there's something before it. Yep. Okay, because you want both anywhere where it's like purple and green. So I can see that all of this, they overlap. They don't overlap here, they don't overlap in here, and then from here I'll get started. The negative 2 can be filled in. That can be a hard bracket because it's included in both. The negative 1 is not included in both, so I have to do parentheses. Same with the 1, not included in both. Then all the way to infinity. Okay? That's a tough domain question. It's combining everything there. Anybody questions on it? Yeah. Sure. So when you're doing the number line up here, what I'm looking at are these factors. If they don't have multiplicity, meaning it's not x minus 1 squared, you know, it's just a factor and a factor, linear factors, your number line will always alternate. If it has even multiplicity, that's where it bounces off the x-axis. So on my number line, it'd be doing the same thing on both sides of wherever that 0 is. So like if this was squared, this 0, I'd have matching things on both sides of it. But if there's no multiplicity, just alternate. Or odd multiplicity, it would still alternate. Numerator did not have multiplicity. Let's go back up there. Because this one you didn't, this was just linear, right? X to the first, so you didn't even need a number line to solve that or do anything with it. Does that make sense? Okay. Other questions on that?
Why did we have to include the numerator?
So if we didn't include that, we would have set our domain as everything from negative infinity to negative 1 to infinity. So let's say I plug in like a -5. Is that okay? Right, so we only care about the numerator if it has an even root in it. Okay. Anything else on the warm-up? All right, guys, we're going to do notes for 1.3 today. We are doing some graphing. We're going to look at graphing with transformations and some piecewise functions. So does anyone want graph paper to go along with their notes? Yeah. If you need more later. Well, if you're going to be sketching graphs, that's up to you if you want. If you like precise graphs or not. Call it function families. So we're going to review just the basic functions that you should know what the graphs look like, and then how to graph with transformations, and then a little bit of piecewise graphing as well, okay? So the first graph is linear. Parent function is just y equals x. Let me just search, made a grid. All right, so if you're graphing a line y equals x, hopefully we're good at graphing that one, right? That's just a line, slope is 1, very basic graph. My grid is kind of small here. You know your slope, you can plot a few points. Not too bad. Your second type is quadratic. And that is just y equals x squared. So these are your parent functions for these graphs: 0, 0, 1, 1, 2, 4. Right, our next kind we'll do cubic, which is just y equals x cubed. What does that one look like, guys? Yeah. No one can ever describe it. It's just this one, right? Look at that graph down there. So for cubic, guys, your basic points, there's 0, 0, 1, 1, and then 2, 8. Okay, if you think about plugging that in. 1, 2, 3, 4, 8. -1 gives you -1, -2, -8. All right, after cubic, we've got square root. Starts at 0, 0, 1, and then 4, 2. That's it. Got a few more, guys. All right, our next one is cube root. So we did cubic, now we're going to do cube root. Y equals cube root of x. So again, you start with 0, 0, and 1, 1, but then instead of 2, 8, it's 8, 2. Okay. Next one, absolute value. Absolute value of x. 0, 0, 1, 1, 2, 2, and then left side as well, negative 1, 1, negative 2, 2. That one you're usually pretty familiar with. We've just got one more. The last one is rational function. And your parent function for that is just y equals 1 over x. So this is a graph that has a vertical asymptote at 0, a horizontal asymptote at 0, and then your points, they're kind of tough to plot. 1, 1 is 1 point. 2 will give you 1/2. 3 would give you 1/3, 4, 1/4. Like they're just getting closer and closer to that x-axis. And same as you go vertically, like 1/2 would give you 2, 1/3 would give you 3. So the graph just follows these asymptotes. So you've got like the first quadrant piece. It's not going to cross it, it's just going to approach it. And then same in the third quadrant. You've got -1, -1, -2, 1/2. Okay. Really, on the rationals, I'm looking for, are your asymptotes in the right spot? Do you have the general shape there? I'm not looking for you to plot like 7 points on each side of this, okay? So feedback from what you guys learned last year. Are these familiar to you, or are you like, some of these, I don't really know what's going on with them? What do you think? Familiar? Nodding? Sort of? Okay. All right, good. So now we're going to graph some of these, but with transformations. So we're not going to sit there and make a table of values and plug a whole bunch of things in. We're not going to use Desmos or a calculator. You're just going to use a transformation of these parent graphs to graph your new graph. Let's try some examples. So let's start with y equals quantity x plus 2 cubed minus 3. So first with this one, guys, transformations. When I say transformations, what I'm talking about is shifting up, down, left, right, reflecting across a certain axis, vertical stretch, horizontal stretch or compression. That's what I mean with transformation. So I see 2 transformations in this one. Do you guys know what they are? Which way is the graph going? I saw down. Yep. Left. It's what would make that 0 because it's your x-intercept that's moving there. So left 2, down 3. So again, we're not going to plot and plug in a bunch of values here to figure this out. Think about what the parent graph looks like. I'm going to plot those parent graph points and then we'll just shift them from there, okay? So if it's the cubic, I know there's that 0, 0, 1, 1, 2, 8. I'm going to plot all 5 of those. All I want you to do is take each point and move it left 2, down 3. You're just shifting that entire graph, left 2, down 3. 2, down 3. I always like using different colors for this so I don't get like lost in my dots. There's lots of ways to go about graphing these. You can just think about where that center point shifts to and then graph it from there. That works as well. We okay with that first one? Okay. All right, let's do y equals negative square root of x plus 3. So what sort of transformations do we have going on in this one? Yeah.
Flip and the left 3.
Yep. And what are we flipping over, the x-axis or the y-axis?
X.
Good. So we're going to flip over x-axis. And you do want to get in the habit of doing that reflection first. It's like order of operations. You'd multiply by the -1 before you'd add or subtract something. So we want to go ahead and do our reflection first, and then we can go to the left 3. It doesn't matter always. Sometimes you can do them in whatever order you want, but there are occasions where it doesn't matter. So I'm going to, again, plot just a few points from that parent graph. So this is a square root function. So I'd start with that 0, 0, 1, 1, 4, 2, my parent graph. And I'm going to flip over the x-axis and go left 3. You can do that in 2 steps if you want. I'd do it in different colors if you're doing that, otherwise you have a lot of dots. Or I can just do it right away and go in order through my dots. So the point that's at 0, 0, flipping that over the x-axis, that doesn't do anything to it. So I can just go left 3 with that guy. 1, 1 would flip right down there to negative, I'm sorry, 1, -1. And then I have to go 3 to the left. And then this would come down here to 4, -2, 1, 2, 3. So there is what my final graph looks like. Are these transformations familiar to you guys? If you remember doing these? Okay. We're doing them in your notes here with parent graph functions. You could always plug in values to check. It's important that you understand what the transformation is, because sometimes I will give you a graph that doesn't have an equation, and then you're going to have to shift it. And that's actually what we're going to do next. I have a worksheet for you here that you're going to partner up to do, where your graph is just this weird drawn function, and you have to do all of the transformations to that. Okay. So I know we only did a couple of examples here, but guys have the general idea of what's happening there with transformations. Okay, so let me pass this out. Work on it with a neighbor. There are two sides. Okay. This one with kind of the absolute value will be function to this side first. Okay. I should have pulled one for you. Sorry. Okay, so everyone understands this is the function that you're doing the transformations to. So you're just given this graph. Now you have to do the function plus 1 or the function of x minus 3. It's all just taking this graph and shifting things around, okay? Are you kind of okay? If you're like, what is happening? So like the first one that says f of x plus 1, you would just take that whole graph and move the entire thing up 1. Okay? So when the negative is out in front, so like the negative 2 f of x, that one, your y values are what are changing sign. So you're flipping over the x value on that one, over the x axis.
And then for the next one, you would be over the y.
The x is actually changing. Yeah, does that make sense?
Yeah.
I always have to think through it. Like, you can't just memorize it. I'm like, well, what's happening? Oh, that's okay. I'm going there. And sometimes it helps to kind of like label these points. So to go, okay, this is -1, -1, this is -3, -1. So when you're stretching, you know, oh, I'm multiplying that by a -2. You know, it's just easier to see sometimes. Some won't fit, that is correct. Just do the best you can.
When it's like f2x, don't I have to multiply that by 2?
Ooh, no, you actually do the opposite.
Oh, it's y value?
No, you multiply the x values by 1/2. This is probably the trickiest one right here. So you know how, I think the easiest way to remember it, you know if it says x plus 2 in the parentheses, you go to the left, not the right, correct? So you do the opposite of what it looks like you should be doing. It's the same thing with the coefficient in there. You do the essentially the reciprocal.
I should be able to cut it in half.
If it says f of 2x, you would cut it in half. Which one are you talking about?
For the -2f of x, I cut the y values in half.
Nope, that's outside. You do exactly what it says. It's the inside stuff that's weird.
Okay.
Like, you know what I mean? If it's, like, let's say it was x plus 3 and minus 2, you'd still go down 2, right? Like, that one is what, anything that's outside the parentheses makes sense. Inside the parentheses is the opposite of what it seems like it should be. Yeah, no problem. The horizontal stuff?
No, the stretching.
Yeah, okay.
I don't think I was ever told you.
I imagine there's going to be a lot of moments this year where you're like, oh, that's okay.
So then if it's f of 1/2 x, then it's double.
Yes, you got it. Nice. And guys, I will put the key up here for the front once I see most people are at or near the end of the front. So you can sure move on to the back. Done. Check with each other, make sure you're doing okay.
I forgot those.
Oh,
Yeah.
yeah.
So this one, I just like stamped it.
I know.
Oh, that's the.
Out of practice of reading upside down.
found
So fun.
Yeah. The X value is Y.
you look at
Should I put a picture of young
it's like the email
Should I put a picture of
what?
Yeah.
Or I can say, or I can say ready to this, and I'll put this.
My sister said that. Not surprising. Sounds like an average.
Do we, so after each transformation, do we continue from that? Or do we,
No, go back to the original.
okay.
How do you where do like this multiplying?
Yeah. Well, so this is the easiest one. So it's saying the opposite of that. So your X values are changing signs. Do you think that's a reflection over the X axis?
Why?
So all of these points.
What about like
Okay.
oh I did that.
Yeah.
Getting back into math. Warming up, just warming up.
We'll get there. Okay.
Divide them.
So it's like.
Multiply.
Yep. So when it's inside like that, it's X values.
Is this a plus or plus 2? Okay, that's what I think, but I don't know.
Looking for order operations, multipliable words. Yeah. And I see a few of you are getting to the back, so I'm going to go ahead and pull the key up here for the front. Don't look until you're ready, it's fine. But if you're ready to check, I wanted to make sure it was there for you. Give me a second. Guys, I know that's not huge. Can you see it? Or are you like, what? I cannot tell. I zoomed in before so that we could do it like half at a time, and it made the entire thing disappear. So let me try it one more time. It's going to work. Oh, yay. Okay. That's better, right? Okay, we'll do it like... Yeah. Yeah, I was going to say this one probably is very commonly missed.
Yeah.
Yes. So guys, this one, let's talk about when you have a coefficient inside with your x, what you're actually doing, okay? If you think about it, anything that's inside, it does the opposite of what it seems like it should do, right? This says -3, but we're actually going to go to the right 3. So if it says multiply x values by 2, what are you actually going to do with your x values? Yeah. So this would be, you can either think multiply by 1/2 or divide by 2. So x values times 1/2. Okay? So just remember, if it's a transformation inside with your x, think about doing the opposite of what it actually says. And only the x values would change. And so then if we look at this one where it's 1/2 x, you see how that one is where you multiply by 2. So you just want to switch those two graphs and you'll be fine.
Thank you.
Yeah, no problem. For this one. Yep. Yeah, I'll scroll down in a minute. All right, guys, I'm going to go ahead and, is it okay if I scroll down? This one?
Yeah, is that correct?
Do you see faintly I have the scale going 2, 4, 6? Yeah, because it gets really big. I cheated. And again, once you're done with the front, go ahead and move on to the back. So absolute value, I heard a couple people ask absolute value. I did the 2 absolute value ones for you on the front. So look at those, see if you can figure out what's happening there when you have to do it on the back. See if that helps you at all. Look at the difference and see if you can.
Yeah.
Okay. Yep, let me stand the other side. Look. So, was it, is it
It's inside, yeah. Just in the middle of those two points.
I see this side looks like the same thing. So, if you're doing the absolute value of x, whatever your input essentially, so like a positive 2 here, right? So even if it's like a negative student, absolute value of that is positive 2 for whatever the input. So you're going to have the reflection.
Okay, so oh, okay.
So basically, like this side of the graph will be ignored, and this side will be reflected.
But do I have to review this positive?
So yeah, when you do absolute value, this side's not going to change at all. But those would only come up as positive when you do this.
Okay.
Yes, exactly. Because if you see how this absolute value doesn't have any points on it.
Yeah.
Okay. That one I think is the absolute value is usually extra. Does make your brain a little bit. You guys think the absolute value one for the trickiest?
Yeah. Just
Oh, this side.
do check your X's that
Uh,
Yeah, so the absolute value is outside that's saying sorry. So like anything below the x-axis is just
Yeah.
so like
That's what you put.
you're gonna see that the right side of the graph is just you're just taking like I'm only getting the exact Yes, so when it's outside like this, below the x-axis, which is good, because it wants to be above. And so like, this, or all of this stuff here, and it's above the x-axis.
Yeah.
They just say, because the outside of that doesn't count. That's good. That means this. Like this one, right side of the head, the left side is the right side because you're getting the same output as if you get positive. Okay, it's the left trust. All right, guys, let me pull the key up for the back. Looks like a lot of people are there or almost done. Well, having all sorts of PDF troubles. Here, let me open it again, guys. Sorry. Okay, maybe I'm not going to open it. I don't know why it doesn't like it. So you guys keep working. Ugh, okay, so I cannot open the key. I believe I have it posted on Schoology for you. The trickiest part of this, let's see if just the blank one will open. Okay, the blank one opens. I think the hardest part, guys, is the absolute value ones. So what you want to understand with those, and And I know this is tiny, but I'm afraid if I make it bigger, it'll go away. So like this one where it's the absolute value of the entire function, absolute value of f of x. That's saying the absolute value of your y values. So anything that is below the x-axis here, like what I'm putting in green, that will all get flipped up above your x-axis. So that point will come up. So like that red graph, that is what this guy should look like. That's kind of weird. So anything below the x-axis comes up. If you're going to do a question like this one where it's the absolute value of x plus 1, you would do this absolute value part first and then shift it all left. I'll wait a second here, and then I'll explain the other absolute value. So sometimes your graph looks just completely different once you do the absolute value of it. Do you see it or not? So the part that was already above the x-axis, that just stayed. Because absolute value of a positive, that's not going anywhere. But these that were below, we have to like flip up. That makes sense. It's sometimes hard to draw, but like hopefully that idea makes sense.
Yeah.
Yeah. So then this one, guys, that's f of the absolute value of x. Did you need that still? I heard the heavy sigh. I'll do it again in a minute. Guys, the right side of the graph won't change at all because the absolute value of positive x values, they're the same as they were, right? That doesn't do anything to it. But the left side is going to just become a reflection of the right side. So if you think about putting a -1 in for your x, and then you take the absolute value of that, that's +1, you get the output from +1. So it's going to match what's happening on the right side. So this side is just going to go, okay, I'm matching here. So that's all that graph does. That makes sense. Yeah, so like you're okay with this side of it, right?
Yeah.
Okay. So think about if I were to do like in this, if I was going to find f of -1. That means my x is a -1, right? So when I plug it in there, what's the absolute value of -1? Okay, so really what I'm finding is f of 1, which I know is, you know, whatever's on the right side. So even though I plugged in a -1, I got the output from +1. So if I did like, I don't know, what's this, 5, -4. So let's say I did f of -4. So that would be absolute value of -4.
Oh, I see.
Right? You good now? Okay. Yeah, it's tricky. Like those are hard. Those are not easy things to figure out. Any other questions on this? And again, I think I already have the key on Schoology for you. If not, I'll put it up there so you can check the rest. Sorry for the technology not cooperating there. All right. Oh, go ahead. Yeah, and you have to think about, am I changing the x or the y to a positive? Did you want me to draw this one again? Yeah. Do you care if I just draw it on here? Okay. That. such a weird little graph, too.
Yeah.
Okay. You can do it. And then guys, I know we're getting close to the end here. We got a few minutes left. I want to do like at least one piecewise function back in your notes, okay? You're good? Okay. All right. Okay. Okay, so first, just to make sure you know what a piecewise function looks like, I think you do, but I'm not going to assume at any point this year that you know exactly what I mean. So, like, it might say something like f of x equals 2x when x is greater than or equal to 3. It equals 5 from -1 is less than x is less than 3. And let's say I'm doing a linear one to start with. Maybe it's -3x minus 5, and x is less than or equal to -1, okay? Jot that down and see if you can graph that. Do you guys remember graphing piecewise? Or are you like, nope?
No.
Nope? Oh, okay. Hey, that's all right. You're like, what are you writing? What is all of that? It's okay. We have 7 minutes, guys. We can do piecewise in 7 minutes. Okay, so it's called a piecewise function because you have multiple pieces that you're graphing. All right. The example I've given you, the 3 pieces are all linear graphs. We're just going to start with that. They will not always be linear for you. They could be any of those function families, like the parent functions that we talked about. But we'll start with linear to make sure you get the idea. So I'm going to graph this first piece up here in green. Now, if I just said graph the line y equals 2x, I'm confident you guys could all do that, okay? But I only want you to graph it from 3 to infinity. So there's a couple ways you can do that. You can graph the entire line, starting, you know, y-intercept, slope, all of that, and then erase what you don't need. I like to start at the end point, because these are going to have endpoints here. It starts at 3, right? So if I plug a 3 in, what do I get for my y value? Like, what's the starting point? 6, yeah? So 3, 6 is where this piece of the graph is going to begin. 1, 2, 3, 4, 5, 6. Now, do you guys think this is going to be an open dot or a filled in dot? Filled in. Okay, good. We got that. Now, again, from here, you can use your knowledge of the graph, you can count slope, or you can even just plug in another point that is bigger than 3, because it says x is greater than or equal to 3. So what if I plugged in a 4? What would I get? 8. Okay, so over 4 up 8. Again, you obviously could have just counted slope, right? Up 2 over 1. But that's my first line. I start at the end point and I connect through, and it's going to keep going because it says for anything greater than or equal to 3. Okay? All right, I'll do my middle piece in red here. Now, if I just said graph the line y equals 5, what would you guys graph? piecewise. Yeah, so horizontal line, good, right? At 5. I only want it to go from -1 to 3. So my endpoints are essentially -1, 5, and 3, 5. Okay, like I've just got this little piece in the middle of my graph. Are these going to be open dots or closed dots? Open, good. -1, 5. And 3, 5, open dots. And then in between them, you just graph your nice little horizontal line. Okay? And we just have one more piece. I'll do that one in purple. Again, I like to start with the endpoint just to kind of know either the beginning or the end. So if I plug in -1, what do I get? -2. Yeah, my brain was a little slow with that this morning too. So -1, -2, and I think we're okay with that's going to be a filled in dot. Okay, again, you can count slope. Just make sure you count it in the right direction, because I want everything less than or equal to -1 now. I don't want stuff to the right of this. I want things to the left. So I can count slope, or maybe I just want to plug in -2. Okay, because that's an x value less than or equal to -1. What do I get when I plug in -2? Good. So -2, 1. Start at your starting point and connect through. So that was a pretty quick version of graphing piecewise, but does that make sense to you guys?
Yes, I remember that.
Oh, okay, you've done it before?
Yeah.
Yeah, okay. And again, lots of ways for how you get there. I don't care as long as you graph it right. Double check at the end that your graph is a function. If you end up with like multiple pieces crossing in the same spot, you messed up somewhere, okay? It should be a function. All right, guys, there is math-based homework. That's not due until Monday night at 11:59. It's always the next school day at 11:59, okay?